And today we are discussing the network core. Okay, so the network core means here arise the two method, that is that circuit switching and packet switching. That is here we are using the network core, that is the mesh of routers that interconnect the internet's end system. Okay, so how the routers will route the packets to the destination. So here we are using two methods, that is circuit switching and packet switching. Okay, in circuit switching there should be a dedicated link should be established between the end systems, or a dedicated path should be established path should be reserved for the entire duration of the communication. Okay, in packet switching there are not reserved, that is a session message use the resources on demand. So if that at the requesting time, if the resources, all the resources are in use, we have to wait for access to the communication link. So in circuit switching there should be a dedicated circuit should be reserved for the entire conversation. The best example for that circuit switching is our telephone network. Then the packet switching, data sent through the net in discrete chunks, and there is no dedicated path between the transmission, that is the sender, and the receiver. So in order to start a session, they use the resources on demand. As a result, if all the resources are in use, we have to wait. The best example is, that is, if we are going for a dinner at a restaurant, we can choose two options. The first option is we have to reserve a table at the restaurant before if we are coming out of our home. We call the restaurant that is there any table, and we specify the time, say 8 p.m. to 9 p.m. So how many people, so we have to reserve a table. Then if we get the confirmation, then at the time we can enter into the restaurant. At the same time the table is reserved for us, so we can go for the dinner. But if we are going for without reservation, okay, if all the tables in that restaurant are full, then we have to wait. These are the difference between the packet switching and circuit switching and packet switching. For circuit switching, there should be a reserved path for the entire conversation. But in the case of packet switching, there is no such reservation. Okay, so here in circuit switching, that the entire bandwidth of the network, then the resources, then all the circuits, all are dedicated for that particular conversation. Okay, so the connection established between the sender and the receiver before starting the communication, that connection is known as a circuit. When the circuit establishes a circuit, okay, it reserves the constant transmission rate. All the bandwidth has been reserved for the sender to receiver connection. So the sender can transfer the data to the receiver at the guaranteed constant rate. Okay, so the network resources is in circuit, then here it is in the network resources example, bandwidth that are reserved into pieces in packet switching. Okay, the pieces are allocated to the cords. Then here it is, the circuit switching is divided into two. Then here using two different methods of circuit switching, that is frequency division multiplexing and time division multiplexing. Okay, in frequency division multiplexing, the entire frequency, okay, is divided among the users. Okay, the entire this is the multiplexing schemes. That multiplexing scheme means that network resources are divided and the divided network pieces are allocated to a core. Okay, so the resources piece is idle if not used by that all in call. First it is allocated, then if it is not used by that call, then that network is idle. So here it is, we have that we can divide the two types of dividing the link bandwidth into pieces, either the frequency or the time. So here we have frequency division multiplexing and time division multiplexing. So in frequency division multiplexing, in frequency division multiplexing, that allotted frequency is divided. That is, the best example is that FM radio, the bandwidth, the allotted bandwidth. Okay, so the FM radio stations are allotted the bandwidth between 88 megahertz to 108 megahertz. So among this 88 megahertz to 108 megahertz is divided among different stations. That is why here we are using the 99.1, 104.8, etc. So that particular frequency is allocated to that particular station. Okay, 90.9, 91.9, 104.8, 101.4, like that. So each and every station is allotted that particular frequency. That frequency can be used by only that station. Okay, any other station cannot use that particular frequency. But in the case of TDM, the time is divided. Okay, so the time duration is divided into fixed duration. So each frame is divided into a fixed number of time slot. So when the network establishes a connection across the link, the network dedicates one time slot in every frame to the connection. After that time slot expires, he can wait for the next time slot to come. Okay, so during a particular time slot, the entire frequency is allocated to that particular connection. So this is the difference between FDM and TDM. Okay, so here it is. If we want to send a file of 640,000 bits from host A to B over a circuit switched network, then here it is, all links are 1.536 megabits per second. So here it is, all links are 1.5 divided, whole to be divided. Then each link uses a TDM of 24 slots per second. So we have to divide that each and how many seconds are to be needed for that connection. Then for that circuit, in order to send that thing, so host A to B, the all links are 1.536 megabits per second. Then each take 500 milliseconds to establish end-to-end circuit. So in order to transmit this thing, each circuit has a transmission rate of 1.536 megabits per second. Then it uses a TDM of 24 slots. So 64 kbps is a second. So it takes 10 seconds to transmit the file. To this 10 seconds, we add the circuit established time 10.5 seconds to send a file. Okay, so here it is, 10 seconds if the end-to-end circuit passes through or 100 links. It takes the 10 seconds of time to transmit the data. So next we have the packet switching. Packet switching is each end-to-end data stream is divided into packets. User A and B packets share the network resources. Each packet uses its full link bandwidth. Resources used as needed. Only on demand they use the resources. There is no reservation. Okay, so the chunk of data to be transmitted is known as the packet. So here we are using store and forward method. In store and forward method, the packet switching means at the input to the link. Store and forward transmission mean the switch must receive the entire packet. Okay, so if there are different end system to be go through for the entire transmission, so one switch should receive the entire packet. After receiving the entire packet only, it transmits it to the next host. Okay, so the store and forward packet switches introduce a store and forward delay, because here it has to store the entire packets, then only it will forward the packet. Okay, so there is an store and forward delay will be there. So each packet switch has a multiple links attached to it. For each attached link, the packet switch has an output buffer which stores the packet that the router is about to send to that link. The output buffers play a key role in packet switching. If an arriving packet needs to be transmitted across a link, but it finds that the link is busy with the transmission of another packet, the arriving packet must wait at the output buffer. This is known as queuing delay. So first it has the storing delay. The entire packet has to be stored. Then it has to be transmitted to an output link. Suppose that if that output link is busy, then it has to wait. So that is the queuing delay. Okay, so there are two types of delay. One is store and forward delay and the next one is queuing delay. Then in this here also the chance for losing a packet is also possible. Okay, so here it uses the statistical multiplexing, SDM. The link transmission capacity will be shared on a packet by packet basis only among those users who have packets that need to be transmitted over the link. So such on-demand sharing of resources is sometimes referred to as statistical sharing. That is, each host get the same slot in resolving the TDM frame. Here it is, A and B packet does not have fixed pattern, shared on demand. That is statistical multiplexing. Okay, so that circuit switching uses frequency division multiplexing and time division multiplexing, whereas the packet switching uses statistical multiplexing. Okay, then which one be the best? Whether it is the circuit packet switching or circuit switching. Packet switching allows more users to use the network. Okay, then the circuit switching is 10 users, then the packet switching for that same use it allows 35 users. So here we are using, if we are telling packet switching versus circuit switching, we assume that the packet switching is the winner. Okay, so it is great for busy data, bursty data. Resource sharing has been implemented and simpler, then there is no use of no call setup. Then excessive congestion, packet delay and loss are the disadvantages. But if this type of disadvantages occur, we assume that packet switching is more beneficial as compared to circuit switching. Okay, so this is all about the network core, that is the two types of switching techniques, circuit switching and packet switching. In circuit switching, the entire circuit to be reserved before transmitting the data. Packet switching, there is no such reservation, their resources are reserved on demand. Okay, then the packet circuit switching uses two types of multiplexing, frequency division multiplexing and time division multiplexing. And here in the the circuit switching, the packet switching uses packet statistical division multiplexing. Okay, statistical multiplexing of resources. Okay.